Hello everybody, we're going to do 4.3 rate problems today in your SAT Math Level 1 test prep. Email me here if you need supplies. 4.3 rate problems, part 1. We have 30 points here of notes to take. Hopefully you have your note-taking guide out. And we have a 44-point skill sheet, which is at the end of this PowerPoint, and if you need those, if you need skill sheets, email me for that. Notebook here, overview of this section here. A ratio of two quantities that have different units of measurement is called a rate. For example, if a car travels a total distance of 150 miles in 3 hours, the average rate of speed if distance is traveled by the amount of time required to travel that. So here, the rate would equal distance over time, 150 miles over 3 hours, which would equal 50 miles per hour. Rate problems are usually solved using the general relationship rate times B equals A. You are using the correct rate relationship if the units check, as in rate times time equals distance, miles per hour times hours equals miles. Unit cost. Unit cost of problems. Unit cost problems require you to figure out a rate by calculating cost per item. Multiplying this rate by a given number of items gives total cost of those items. So for example here, if 5 cans of soup cost $1.95, how much do 3 cans of soup cost? Since 5 cans cost $1.95, the cost of 1 can could be 39 cents. Per can. To find the cost of 3 cans, multiply the rate $0.39 per can by 3, and that would give you $1.17 here. Solution 2. The number of cans of soup varies directly with the cost of the cans. Form a proportion in which X represents the cost of 3 cans of soup. So we cross multiply here. 5x equals 3 times $1.95 equals 5.85. That'd be another way to do it. And then we divide through again by 5 and we get $1.17. The cost of 3 cans of soup is $1.17. Motion problems. The solution of motion problem depends on the relationship of rate times distance. So, for example, John rode his bicycle to town at a rate of 50 miles per hour. He left his town for minor repairs and walked home 3 miles per hour, excluding time spent taking a bike into the repair shop. Trip took 3 hours. How many hours did John take to walk back? So, number of hours John took to ride his bicycle, we know that. So 3 minus X equals number of hours John took to walk. So here's our rate times time equals distance to town. Here's our 15 times X hours equals 15X. Return trip 3 miles an hour, 3 minus X equals 3 times 3 minus X. Since John traveled the same route, the two distances must be equal. So here 15X equals 3 times 3 minus X, and we solve for X, we get 1/2 hour. John took 2.5 hours to walk back. Work problems here. When solving a problem involving 2 or more people or pieces of machinery, use these relationships. Takes time to complete an entire job. Rate of work times actual time worked equals fractional part of job completed. So suppose John can mow a lawn in 3 hours. Maria can mow the same lawn in 4 hours. Number of hours X it would take them to mow the lawn working together is given by the equation here. Part of job completed by John, part of job completed by John, part of job completed by Maria. 1/3 X and then 1/4 X equals 1 job. So a new printing press can print 5,000 flyers in half the amount of time it takes for an older printing press to print the same 5,000 flyers. Working together, the two printing presses can complete the entire job in 3 hours, how long would it take the faster printing press working alone to complete the job? If X represents the amount of time it takes the slower printing press to complete the job alone, then the job in X over 2 hours. Hence, 1 over X times 3 plus 1 over X divided by 2 over 3 would equal 1 job. So we have 3 over X plus 6 over X equals 1. 6 equals X. Since the slower printing press would take 9 hours working alone to complete the job, the faster press would take 4.5 hours working alone to complete the job. So that'd be a way that you would do a work equation there. 1 over X represents part of the whole job completed by the slower press in 1 hour. 2 over X represents part of the job, whole job completed by the faster press in 1 hour. 1/3 represents the part of the whole job. So that is completed 1 hour with both presses working together. You can get this PowerPoint, not the video, if you want the PowerPoint. Email me here, worksheets, online tutoring, etc. Thank you.